Cool. So now we're going to look at asynchronous programming, how it's slightly different. But one of the first similarities is just this is computer science, this is programming. You still want your program to run fast, right? The subtle difference here is that you want to create an efficient UI that reacts fast, because your program runs for an extended period of time, and basically your client determines when your program ends, right? So it's not about running from beginning to end. It's about how do we render the thing that they wanted as fast as possible. And so we're going to look at kind of a really important difference here. So in a synchronous program, you have this kind of looking thing, like just from the beginning to the end. But in asynchronous programming, I just put non-blocking here just to kind of mean the same thing. You don't know what's going to happen fundamentally. I could, as I am about to, press the up arrow, or I could press the down arrow, or I could press the left arrow or the right arrow. But you just don't know what's going to happen. You don't know ahead of time what the user is going to do. You can do your best to guess, but you don't know. And so that's why it's really asynchronous, because your execution is not up to you. It's up to the user, right? So just to drill that in, here's a quick little demonstration, right? So you can have on-click and then an on-keyboard press, which makes the program execute in this way, or you can have an on-mouse up and then an on-click after. And there are like billions of combinations of different program executions. And that's going to fundamentally determine what your program looks like. So each one of these things, on-click, on-keyboard press, on-mouse up, these are all things called I/O events, okay? And they happen in both synchronous and asynchronous programs. But the difference is that in synchronous programs, what happens is that as soon as something like that happens, it blocks your program. And by block, I mean literally main pauses for a second. So when you press L or something, or G if you're trying to go to Google, your OS, your operating system, has to detect that somebody has pressed the keyboard from a hardware device and then translate that to software. So while that's happening, your main program needs to literally stop, and then it needs to resume, and then it needs to stop, and then literally resume again. That's all fine and dandy. Your OS handles that fine. And so that's all fine and dandy. So basically your OS is going to stop and handle that for you. But it's the point here is that it's very different from front-end engineering, because in front-end engineering that happens so much. Like every single time I'm pressing an arrow key, it has to react to that. But we can't block the UI thread, because when you block the UI thread, literally you can't do anything. You saw in the Philip Roberts talk what happens when you make multiple synchronous requests. Your browser literally stops. Your UI no longer renders. So you can't handle it in the same way that synchronous programs do, which is to handle it at that point in time, which is why we need things like asynchronous programming. And in this diagram, you can kind of see that. So what happens is when you have an on-click, for example, it's going to go into your callback queue as opposed to being handled immediately, right? And so that way, your browser can keep executing, and when it's free to handle that click event, it's going to handle it, okay? So how do we make programs execute fast in front-end engineering? There's like two really important topics, and we're going to examine how they were implemented in V8 in JavaScript. First one is pull things off the function call stack as fast as possible, that UI thread. Because as soon as something is on top of that thread and it's just like running for a long period of time, your browser stops, right? So it's not a good thing. And the second point is you can use multi-threading in asynchronous programming, but it's not quite multi-threading. It's like being just kind of clever about how you would be able to execute different things at the same time. Now, before we dive into that, I just want to make a couple pros and cons about asynchronous programming. The first is that there's no deadlocks and races. So suddenly your program is a little bit easier to reason about, especially when you have so many things happening at the same time, which is the nature of front-end engineering. You have one stack, one thread, which makes it also easier to reason about. It's easy to approach, but it's really tough to master. There's a low overhead, so you can run multiple tabs in Chrome. You can do things like that. It's resilient. If you go around different websites, your program JavaScript fails like all the time, but you can just like handle it, make it show up, and then make it show up as an error like you did the other night, like console.log it out, and then continue to run the program. Now the cons are that your programs must never block, and we talked about this before. If your UI thread blocks, it's over for you. Like your browser's gonna crash or it's gonna just freeze up. And so the thing at the function call stack at the top just need to finish as fast as possible. Now the third con is kind of in contradiction to what I was saying before, but programs are harder to reason about in certain cases, and that's mainly with callbacks on callbacks on callbacks on callbacks. This is really a debatable point. The way I think about it is that this is the paradigm that you need to be in order to do front-end engineering. And a lot of people will debate that, oh, it's way too hard to reason about. The guy who made JSON, Douglas Crockford, he kind of thinks, in my fashion, that this is the way it is and this is the way it should be. And so you can form your own opinion on that.